G'day everybody, Patrick here, and welcome to part 4 of the serverless framework tutorial. Today we're going to be looking at how can we integrate our serverless applications with a database, specifically using DynamoDB. To start with this, I have taken the O3 folder, which is available on the GitHub, by the way, the plugins one, and I have basically copy-pasted it into the database. So you can see here, and then I have deleted all of these functions that we had, deleted the references to those functions. So that's the starting point for this tutorial. So I recommend you do the same. Leave the plugins though, and leave all the other stuff intact. So what we're gonna do to start with for this database is we actually need to create the database. And so we're gonna be using DynamoDB. Now there's two ways you can do this. Number one is you could just create it from the AWS console, and that would be fine. So the way that you would go about that is you would go to DynamoDB, and in DynamoDB you would click create table. So DynamoDB is sort of like a database table as a service rather than a database as a service. Make sure that you're in the right region. So I'm in AP Southeast 2 for serverless, so keep it in the same region, otherwise you're going to end up like my anecdote from the second lesson. So we're going to create a table, and we name the table, give it a primary key, and so on. But we're not going to do that today. We're going to actually take it a step further, and we're going to declare this in the serverless.yaml. That's where things get really interesting. So we're going to leave the functions blank for a little moment, and I'm just going to copy some things here real quick, and then I'm going to type them out one by one and explain what's going on. So basically, what we want to do is we've got our functions, blah, 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 and then we're going to go underneath that, or really anywhere, it doesn't matter, it's just YAML, which turns into JSON, which is just keys and values, right? So you can do it any order you like, but I like to keep it clean, put this at the bottom. We declare the CloudFormation resources that we want to add to Serverless Framework. So now's a good time to talk about Serverless Framework and how does it work and what it's actually doing. And so what Serverless Framework basically does is it zips up all your code, puts it into an S3 bucket, and then creates a CloudFormation template that references that S3 bucket to get the code. And then it'll handle things like API integrations for you. That's quite nice, but we can actually go a step further and create our own parts of this CloudFormation that we want to add. And the way we do that is with this weird little double resources thing. So the first resources is telling it, okay, this is where we're doing CloudFormation from this point. And then capital resources is specific to CloudFormation. And we're going to name this, I've already created one called key value store, so we're going to need to name this something else. So let's type this from scratch. Resources, and then capital R for resources. And then instead of calling it key value store, let's call it our restaurant database. The reason we're going to do that is we're going to make a restaurant ordering system in the coming lectures that relies on this database. And so we are going to call it restaurant database. So what we're going to do is we're going to go type AWS : so 2 colons here, DynamoDB : table, properties, table name is the thing that we call it here, restaurant database, and attribute definitions. So this is where we determine the specific attributes that we want to define in the DynamoDB table. Bit of context here, DynamoDB is what we call NoSQL. So some people like to say this is not only SQL, but basically it means it's a version of a database that doesn't, that you don't query using SQL. It's got its own language for that and its own system using the AWS SDK. As a result, we only really need to declare the primary key, and if we wanted to have a range key, we could declare that as well. Plenty to learn about DynamoDB, and I'm not going to go too in depth with it today, just the things that you need to understand to get this working. So we're going to go attribute definitions, I'm going to go attribute name is key, and attribute type S for string. So you've got S for string, N for number, and you've also like string lists and objects and things like that. So you can have pretty much any JSON structure is going to work. Then we're going to go key schema. So this is declaring what our key is going to be made of. Attribute name is again just key, and you can call this whatever you like. I'm just keeping it simple with key. In fact, let's change this and call it name. So what we're going to do is we're going to be connecting a name to an order. So someone creates an order in a restaurant, they've got their name and they've got their order. I'm going to keep it very simple, not use any like timestamps or anything, but you could, if you wanted, go beyond that once we've done this. So key type is hash. So there's two types of keys. You got hash keys and you got range keys. Timestamp's a good example for that. So if you want to see all of the values between last Monday and the Thursday before that, then you can split into that date range. Whereas we're just going to be using a single thing, name versus order. So then we've got provision throughput This is where we get kind of specific about DynamoDB. So we have read capacity units is 1 and write capacity units is 1. This is pretty low. You'd use more than this in anything remotely production related, but it's not going to matter for us because we're just testing and playing around. You get 25 free read capacity units and write capacity units in the AWS free tier. So if you created your AWS account less than a year ago, this is not going to cost you anything. Otherwise, it'll cost you like a pretty tiny amount. We're going to delete the resources at the end, but like let's say you leave this up for 2 days, it's going to cost you like 10 cents. It's not much. There we go, resources all done, and we can delete this. Cool. So that is declaring our table, and we've given it a name, restaurant database. Now we need to declare a function. We're going to create 2 functions for this one. We're going to have a function where we can list all of the existing orders and a function where we can create new orders. So let's start with the function to create new orders. So we're going to call this post order, and it is going to be we're going to have handler is post order.handler, then events is HTTP. And for the HTTP event, we have method is post. Oh, no, method is post. And path is /order or /orders. And then we're going to have list orders. So that's going to be handler is list orders.handler. Events is HTTP method get and path orders. So you can reuse the path as long as you have a different method. So we've got 2 different things here, and we're going to create this file. So post order.js, and we're going to say module exports.handler equals async function like this, just as a placeholder. And then we're going to go list orders is the same. So we should be able to deploy this and actually have it work. And we are going to need to deploy this for the first time before we can start using the database. So we're going to do that now, and it may take a little while. This is actually reusing the deployment from before because we've reused this service name. So it won't take as long as if it was completely new, but it still may take a little while. So I'll skip forward until that's done. All right, so this is uploaded. Now you may have noticed something here, which is that the service has ballooned in size up to almost 30 megabytes. And the reason for that is the package.json. We've got 2 dependencies here. These should actually be dev dependencies. And they are making this package a bit larger than it should be. Now, the fact that they're dev dependencies should actually mean that they don't get packaged anymore, so we should be okay. It should be a bit smaller. But just something to note is that if you do have a lot of dependencies, you're going to be spending a while uploading these files. And that's okay, but normally what you would do is you would use a CI/CD pipeline to handle this for you, and the upload is going to be a bit quicker. And then it's also going to not need to be run from your own computer. Lots of different advantages to CI/CD. So I might run a tutorial of doing that in another video, but for the moment, we're just going to be deploying from our local computer. And okay, here's where we're at. So we've got post order and list orders. Let's do the post order first. And we've got this handler, and we've got event and context. Bit of info about the context, by the way. That just provides info like the name of the Lambda function, the AWS region, things like that. So things that don't directly relate to the invocation of the function, but relate more to, well, the context of where the function is being executed. In my experience, I haven't had to use it that much, but I use event quite a bit. So now what we're going to do is we're going to get the event. We're going to do this try thing again as well. So basically the same as what we did last time. Let body try const body equals JSON.pass event.body, and then if that fails, hang on, we don't need a const there. What am I on about? So, and then if that fails, what we do is we return status code 400 and body is, yo, don't do that. No, just say, please provide a body. So then the next thing we want to do is we want to go if not body and body dot. Okay, what do we want to pass in here? So we're making an order. So we're going to need the name for the order, and then we're going to actually need the order itself. Both of those will just be strings. And if it's not defined, we're going to go return status code 400 body. Please provide a name and order. Keep it consistent with the full stop. Okay, and so now we're up to the part of the code that happens if things actually work. So what we do for that is we are going to post this order to the database. Now that we have deployed, this is going to have deployed the database with us. So we can use the name of this database that we created, restaurant database. And just to confirm as well, so I had this one called key value store before. We've got restaurant database and we've got items, blah, blah, blah. No items in there right now. So what we're going to do is we're going to post this item and see if it works. So in order for that to happen, what we need to do is we need to go const AWS equals new equals require AWS SDK. Now this is something we haven't actually got yet. So we need to go yarn add AWS SDK to this project. This is not a dev dependency. This is a production dependency, as we're going to need to use it. And it should tell us how large this is. I've got a little plugin on VS Code that says how large my dependencies are. And it should tell us how large that is. Maybe I need to reopen. And you'll see what we're... Oh, it's not doing it. All right. You'll see what we're actually dealing with in terms of the size of that. So now we're going to go const DynamoDB equals new aws.dynamodb. And then we need to pass in options to this. So there's a bunch of options we pass in here. So you can pass in your access key ID and stuff, but you don't really need to do that, because what will happen from the Lambda side once we've deployed is you'll set up a Lambda role that allows it to do that. We can do it from serverless as well. And what will happen from your side is you will set up credentials on your own computer, and it will just reference those from the AWS credentials folder. So we'll think about this if there's any problems a bit later on, but for the moment we're going, what do we need to specify region potentially? Yeah, so we're gonna say here, and I have mine in AP Southeast 2, it'll be the same region that you created the serverless.yaml in, so it'll be the whichever one it'll match. So region is AP Southeast 2, and then anything else we need to do, I think we're all good. Max retries, params, no, it should be fine. If there's any other issues, we'll get onto that. And then the next thing that we want to do is we want to actually make this do this request. And this is why having an async function is really helpful, because we can wait for it. And so we're going to go await DynamoDB. So this is the one we created here, the DynamoDB dot put item. So maybe this could be a put request, but either way, kind of interchangeable in a way. And then we put the parameters in here for the item. So we're going to need to put the table name. And this is a great opportunity to use the environment variables we were talking about. So we go .env, and in this we can say table, we'll say DDB for DynamoDB, table name equals, and we called it restaurant database. You can have an spaces here or not, it's up to you. So then we're gonna go table name is process.env.table name. And then we need to actually put the item. So here's where things get a bit interesting. So the way you would normally do this is you would have something like, so for the item, we know that the key is just called key, lowercase. So then we'd have like type is string and S, and value is something. It gets confusing and I don't like thinking about it. So what we use instead is a thing called the marshalling tool. And what this does is it formats in a way that DynamoDB is actually happy to work with. So we need to import that. So we're going to const marshal and unmarshal while we're at it. We're probably not going to use unmarshal in this one, but we will in the other one. Is require, is aws.dynamodb.converter. So aws.dynamodb.converter, .marshal and .unmarshal is the function. And so what this does basically is you have an object that is like in DynamoDB format. Let's actually have a look and see if we can say DynamoDB JavaScript put item, and it'll give us a demonstration of what this might look like. Okay, so I found an example of what this would look like, right? So you've got, it says here S for string and so on. So this format is just a pain to work with. So that's what the marshalling tool does. Marshal is going to take your JavaScript object and format it in a way that DynamoDB will accept, and then unmarshal will take the DynamoDB object and turn it back into a JavaScript object. So that's what this is for, and we're going to say here it is going to marshal. We may as well define this outside, so we're going to say const item is equal to marshal, and we need to define this item marshal. We need to define this item as the body, so name is going to be body.name, and order is going to be body.order. Perfect. And so we get item. Is there anything else we need to pass in here that's important? Doesn't look like it to me. Cool. So then we're going to await this. There's a problem though. It says here that this await is going to have no effect. That's because DynamoDB put item normally takes a callback. like that, but we don't want that. We want to use a promise. So we're just going to go .promise. And you can do this with pretty much any AWS SDK method in JavaScript. You can put .promise on the end and it will promisify it, which is really handy. So we're not going to actually wait for the response. It might be an error or something, so you would want to like catch this error normally, but just for demonstration purposes, then we're going to go return 201 created, and body is going to be created like that. So we're going to go SLS offline, and we're going to test this by going curl-x post http localhost 3000 dev, and it was orders, and then we're going to go data to put the content. Name is Patrick, and order is going to be beans. Just really like beans, all right? So there we go. And we got nothing from this because there's an error. What's our error? Missing key table name in params. But it's not. Where's our error coming from? Param validator. So maybe then what's happened is, oh yeah, so it's DDB underscore table underscore name. So this was undefined and then it thought it was missing. Okay, let's try again. Looks better. Okay, it reckons it was created. So now we go to here, we go to DynamoDB and we refresh. And there we go, Patrick has ordered beans. Can't wait for my beans. Okay, so now what we're gonna do is we're gonna go list orders, and we go event context like this, and we're gonna do what's called a scan operation. Now, scan operation, you wanna be very careful with. I'm not advising that you should do this on a big production scale thing. In a real world scenario, you would either not use DynamoDB or you'd use a range key on the table to limit the items to a particular time frame, for example. It's very rare that you wanna actually load every single item from a table, but that's what we're going to be doing right now, just so that we can sort of display everything in a table. You'll see it all make sense when you actually look at the front end we're going to do for this. So what we're going to do is a scan operation on the table, which loads every item in the table and returns it. Pretty simple. We copy a lot of this same stuff, except we're going to actually be using unmarshal this time. So copy that, and then we're not using the body on this one, so it's a GET request. So as you can see here, it was a GET request. In fact, none of this is relevant. So what we're gonna do, first thing we do is check, okay, we're not passing any info from the event in this one, so we don't need to actually verify any of the data the user has sent. We're just gonna make this request and send it back to the user. So we're gonna go const, say orders, equals await, DynamoDB dot scan, and then parameters. So parameters for the scan is just going to be the table name. We don't need anything else. So that's process.env.ddb table name. Now we just need to go to .promise. Okay, so that should be all good, except we're going to say now const orders passed is equal to unmarshal orders. So remember, unmarshal is taking the DynamoDB version of the world and turning it back into JavaScript. So we should get a nice normal JSON object, and then we go, finally, what we want to do is return status code 200, and then the body is going to be JSON.stringify orders passed, which is not what I wrote this. Okay, and that should be okay. So what we're going to do now is we're going to go curl http localhost 3000 dev orders, and by default will be a GET request. And we've got nothing. Okay, so what is wrong with this? Have we got an error? No, it seemed actually like it did okay. So something isn't quite right then. So let's console log the orders and see what the orders have to say to us. Got items, name, I made this mistake previously as well. So we're not unmarshalling orders, we're actually unmarshalling orders.items. You can see here we got items, count, scan count. We don't care about the count or the scan count. Basically, we just care about the items. So we're gonna unmarshal order.items. We run this curl and we got nothing again. Okay, so did I stutter? What's going on? Okay, let's console log orders.items and see if it's what we expect it to be. So then we go here, we got this one. Okay, so it's an So unmarshal works on an object, right? And you can see here we actually have an array. It's an array that contains a single object, but we want it to, in theory, work for multiple objects. So what we're gonna do is something a little bit fancy. We're gonna say orders.items.map, and each item we want to unmarshal. So this is where the functional JavaScript comes in. What map is doing is it's iterating over every item and turning each one of these into each one of these. You can sort of think of it as being equivalent to a for loop where we go I equals 0, I is less than orders.items.length. It's been so long since I did one of these. I++, and then we want to go, orders past, let's imagine it was an empty array to start with, then we push to the array and we would go unmarshal item. That's basically what we're doing, but obviously a lot cleaner. So I really like this sort of functional programming style. You've got map, reduce, concat, and so on. And I recommend you learn it if you're not familiar with it already. It's really great, and it's really common in JavaScript as well. So we're unmarshalling every item, and then that's how we're gonna pass these. I really like the mistakes I've been making. They've been conveniently handy to explain different concepts. So yeah, mistakes are good. So here we are, failed to connect, it's because it's not ready yet. Not ready yet, not ready yet. And there we are, and it worked. We have pretty much made the back end. There's plenty that we could, in theory, do to improve this. And I'm just gonna get rid of this console.log, and I'm also gonna get rid of this marshal we don't need, and then here we don't need unmarshal. Better error handling would be a big one, and you could probably extract some of this functionality like we've repeated ourselves here. But all in all, not too bad, and it works. So let's leave it as is, and I will see you guys in the next video where we start to put all this together with a front end for this application so that users can create orders and view all the existing orders. So if you like this video, please give it a like, it helps me out, and subscribe to the channel if you're not currently subscribed and you want to see more content like this. And I will catch you guys in part 5 of this video series.